Hello. Hello and welcome to this video. As I said in my last JavaScript video that I will discuss strict mode in this video. So here it is. Now, one of the best references, as I have said in many times, is the Modular Developer Network. So here we go. So to understand all this, we may not have covered everything, but things are not very difficult. So let's get started. We will mostly read through it and in between also in my explanation. So JavaScript's strict mode is a way to opt in to a restricted variant of JavaScript, thereby implicitly opting out of sloppy mode. Now what is sloppy mode is the normal mode without strict mode is sloppy mode. Okay. The non-strict mode of JavaScript is sometimes referred to as sloppy mode. Strict mode isn't just a subject. It intentionally has different semantics from normal code. Strict mode code and non-strict mode code can coexist, so scripts can opt into strict mode incrementally. Now there are several changes. One of the changes is that it eliminates certain silent errors by changing them to throw errors, for example, type errors. The second is that fixes make it difficult for JavaScript engines to perform optimizations. Strict mode code can sometimes be made to run faster than identical code that is not strict mode. Prohibit some syntax likely to be defined in future versions of ECMAScript. The first question is, how do you invoke use a strict mode? So it does not apply to block statements. It either applies to entire scripts or individual functions. It does not apply to block including parentheses or braces. Attempting to apply it to such a context does nothing. Eval code, function code, event handler attributes, settings passed to set timeout, and related functions are either function bodies or entire scripts, and invoking strict mode in them works as expected. So how do you invoke it is that you write use strict within double quotes or single quotes. So one of the examples is here. It will apply to the entire script. The second technique is for functions. So consider this function here. You write use script. It will be function level strict mode. And the second function is non-strict function. Okay. Now the use strict directive can be applied to the body of function with simple parameters. The use strict in functions with rest, default, or destructured parameters is a syntax error. So for example, this function receives default arguments, therefore you can't use strict mode here. For modules, it is always enabled. We have not yet discussed JavaScript modules, but if you are interested, you can click this link and go there and read about it. So for example, this is a module. You don't need to say use strict. It is by default enabled. Strict mode for classes, there are three cases. It is enabled for class declarations and class expressions. So for example, class given is there, method test is there. So it is in strict mode. Okay. Now if you try to run this, then it does not work. Okay, because it is in strict mode. Now we take another class expression. This is also in strict mode, but this is not in strict mode. Okay. So trying to delete object or prototype will not throw error, but here it will throw error. Strict mode changes both syntax and runtime behavior. Changes generally fall into these categories. Changes converting mistakes into errors as syntax errors or at runtime. Changes simplifying how variable references are resolved. Changes simplifying eval and arguments. We have not discussed eval. Changes making it easier to write secure JavaScript. changes anticipating future ECMAScript evaluation. So certain aspects we have not studied. So we study the first aspect, that converting mistakes into error. The strict mode changes some previously accepted mistakes into errors. JavaScript was designed to be easy for novice developers, and sometimes it gives operations which should be errors, non-error semantics. Sometimes this fixes the immediate problem, but sometimes this creates worse problems in the future. Strict mode treats these mistakes as errors so that they are discovered and promptly fixed. One of the problems which JavaScript has is assigning to undeclared variables. Strict mode makes it impossible to accidentally create global variables. In sloppy mode, mistyping a variable in an assignment creates a new property on the global object and continues to work. Assignments which would accidentally create global variables throw an error in strict mode. So for example, we have this piece of code in strict mode, and we have a variable called mistype variable. Okay. Now, if you see this, in this one is missing. So what it will do is it will create a property on global object and the code will work. But this is not allowed in strict mode. It will cause an error. The second aspect is failing to assign to object properties. This we had discussed in, I don't remember, last or last to last video. The strict mode makes assignments which would otherwise silently fall to throw an exception. There are three ways to fail a property assignment. Assignment to a non-writable data property, assignment to a getter-only accessor property, assignment to a new property on a non-extensible object. For example, nan is a non-writable global variable. In sloppy mode, assigning to nan does nothing. The developer receives no failure feedback. In strict mode, assigning to nan throws an exception. So here is strict mode, and we are assigning 5 to undefined and infinity. Both are non-writable global, so they will cause type error. Then consider an object obj1 on which we define a property x. This is the property x which has value 42 and writable is false. Now if you try to assign to this property obj1.x value 9, then it is a type error. Now consider object 2 which has a getter x. Now if we want to try to assign to getter only property, it is a type error. Now consider there is an object called fixed on which we invoke prevent extensions with the argument fixed. If we try to create a new property, it's a type error. The next category of errors is failing to delete object properties. Attempts to delete a non-configurable or otherwise undeletable example, it is intercepted by a proxy's delete property handler which returns false. Property throws in strict mode where before the attempt would have no effect. So for example, if you try to delete object.prototype, it's a type error. If you try to delete length of an empty array, it's a type error. In general, you can't delete length of an array. Now, strict mode also forbids deleting plain names. Delete name in strict mode is a syntax error. So consider a variable varx which is just declared, so x is just a name. If you try to delete x, it's a syntax error. If the name is a configurable global property, prefix it with global this to delete it. So if you write global this.x, then it will work. Duplicate parameter names. Strict mode requires that function parameters names be unique. In sloppy mode, the last duplicated argument hides previously identical named arguments. Those previous arguments remain available through arguments. So they are not completely inaccessible. Still, this hiding makes little sense and is probably undesirable. It might hide a typo, for example. So in strict mode, duplicate argument names are a syntax error. So you can't have something like function sum AAC. It won't work. There is also a syntax error in non-strict mode to have duplicate parameter names. If the function has a default parameter, rest parameter, or destructured parameter. Then we have some details with the octal literals. Okay. Strict mode forbids 0 prefixed octal literal. In sloppy mode, a number beginning with 0 such as 0644 is interpreted as an octal number. That is 644 is 420 in decimal if all digits are smaller than 8. Novice developers sometimes believe a leading 0 prefix has no semantic meaning, so they might use it as an alignment device. But this changes the number's meaning. Leading 0 syntax for octal is rarely useful and can be mistakenly used. So strict code makes it a syntax error. So once you have strict mode, you can't lead a number with 0. The standardized way to denote octal literals is via the 0 O prefix. For example, const sum with octal is equal to 0 O 10 plus 8, which is 16. Octal escape sequences such as \45, which is equivalent to percentage, can be used to represent characters by extended ASCII character code numbers in octal. In strict mode, this is a syntax error. More formally, it is disallowed to have backslash followed by any decimal digit other than 0. Backslash 0 followed by a decimal digit, for example, backslash 9 and backslash 07. Setting properties and primitive values. Strict mode forbids setting properties on primitive values. Accessing a property on a primitive implicitly creates a wrapper object that is unobservable. So in sloppy mode, setting properties is ignored, no operation. In strict mode, a type error is thrown. So for example, false.true is equal to empty string is type error. 14.selling is equal to home, type error. With.u far away, type error. Similarly, we have the case of duplicate property names. Duplicate property names can be considered a syntax error in strict mode. With the introduction of computed property names making duplication possible at runtime, this restriction was removed in ECMAScript 2015. So if you have a code like this where we have duplicate properties, then it would be a syntax error prior to ECMAScript 2015. We will look at computed property later when we deal with the explicit reference to spec. Simplifying scope management. Strict mode simplifies how variable names map to particular variable definitions in the code. Many compiler optimizations rely on the ability to say that variable X is stored in that location. This is critical to fully optimizing JavaScript code. JavaScript sometimes makes this basic mapping of name to variable definition in the code impossible to perform until runtime. Strict mode removes most cases where this happens, so the compiler can better optimize strict mode code. So one of the aspects of strict mode is removal of the with statement. Strict mode prohibits with. The problem with is that any name inside the block might map either to a property of the object passed to it or to a variable in surrounding or even global scope at runtime. It is impossible to know which beforehand. Strict mode makes with a syntax error, so there is no chance for a name in a with to refer to an unknown location at runtime. For example, in this case, the obj is not there, but you can invoke the with statement with obj, and that can cause problems. The alternative, assigning the object to a short name variable, then accessing the corresponding property on that variable, stands ready to replace with. Then we have non-leaky eval. In strict mode, eval does not introduce new variables to the surrounding scope. In sloppy mode, eval var x will introduce a variable x into the surrounding function or the global scope. This means that in general, in a function containing a call to eval, every name not referring to an argument or local variable must be mapped to a particular definition at runtime, because that eval might have introduced a new variable and that would hide the outer variable. In strict mode, eval creates variables only for the code being evaluated. So eval can't affect whether a name refers to an outer variable or some local variable. So for example, when we use strict mode, this var x is different than this x. Okay. So it is returning x and the value of that x is 42, which is assigned to eval x. So you can compare x to 17 and eval x to 42. Whether the string passed to eval is evaluated in strict mode depends on how eval is invoked. Block scope function declarations. The JavaScript language specification since its start had not allowed function declarations nested in block statements. However, it was so intuitive that most browsers implemented it as an extension grammar. Unfortunately, the implementation semantics diverged and it became impossible for the language specification to reconcile all implementations. Therefore, block scope function declarations are only explicitly specified in strict mode, whereas they were once disallowed in strict mode, while sloppy mode behavior remains divergent among browsers, making eval and argument simpler. Strict mode makes arguments and eval less bizarre magical. Now we have not studied arguments or eval as such in our videos, but let's proceed for the sake of completeness. Both involve a considerable amount of magical behavior in sloppy mode. Eval to add or remove bindings and to change binding values, and argument syncing named arguments with its index properties. Strict mode makes great strides towards treating eval and arguments as keywords. Preventing binding or assigning eval and arguments. The names eval and arguments can't be bound or assigned in language syntax. All these attempts to do so are syntax errors. We can't say eval is equal to 17 or argument plus plus or plus plus eval or anything like this. Okay, they are keywords and their behavior is predefined. No syncing between parameters and argument indices. A strict mode code does not sync indices of the argument's object and with each parameter binding. In a sloppy mode function whose first argument is arg, setting arg also sets argument 0 and vice versa, unless no arguments are provided or argument 0 is deleted. Arguments objects for strict mode functions store the original arguments where the function was invoked. Arguments I does not track the value of corresponding named argument, nor does a named argument track values in the corresponding argument I. So for example, we have function a in strict mode where a is equal to 42, we assign and we return a comma argument 0 as an array. And then we invoke this with the call f17. So in this case, what will happen is our a will become 42, so pair 0 is 42, and the a which is passed will be at index 0 of argument, so this will be 17. Next aspect of strict mode is securing JavaScript. Strict mode makes it easier to write secure JavaScript. Some websites now provide ways for users to write JavaScript which will be run by the website on behalf of other users, for example online compilers. JavaScript in browsers can access the user's private information, so such JavaScript must be partially transformed before it is run to censor access to forbidden functionality. JavaScript's flexibility makes it effectively impossible to do so without many runtime checks. Certain language functions are so pervasive that performing runtime checks has a considerable performance cost. A few strict mode tweaks plus requiring that user submitted JavaScript to be strict mode code and that it can be invoked in a certain manner substantially reduce the need for those runtime checks. Know this substitution. The value passed as this to a function in strict mode is not forced into being an object, also known as boxed. For a sloppy mode function, this is always an object, either the provided object if called with an object value this or the boxed value of this if called with a primitive as this or the global object if called with undefined or null as this. Use call apply bind to specify a particular this. Not only is automatic boxing a performance cost, but exposing the global object in browsers is a security hazard because the global object provides access to functionality that secure JavaScript environments must restrict. Thus, for strict mode function, the specified this is not boxed into an object, and if unspecified, this is undefined instead of global this. For example, we have function fun and it returns this. So in strict mode, this will be undefined. And if you have fun.call2, then this will become 2. If you apply null, then it will become null. If you call with undefined, it will become undefined and bind will be true. So we have not studied call, apply and bind, but as I said, not everything has been covered. That's why I was not discussing strict mode, but since I said that we will discuss strict mode, here it is. So stack walking properties I will leave for now because we need to study more of JavaScript for this. And this is specification related, so we will not study any further of this. So from here to the end, we will discuss once we complete the language discussion. So I hope that even if you have not understood everything, because I have not explained everything in context, you have some idea that what strict mode does and why we should use strict mode of Java in general. So as we progress through the aspects of the language, we will know more and more that where strict mode can help us. So if you have found this video useful and informative, give a like. And if you need to read it again, you can come to MDN Mozilla Developers Network and study the strict mode here. So do not forget to like the video, subscribe to the channel if you have not subscribed, and share the video on social media and with your friends, because if you do all these actions, then the reach of video increases and more people who need help will receive help from these videos. So the reason I'm asking is for this is that I want to reach to as many people as I can, so that I can help them with their programming requirements. And that is one of the reasons that I put this at the end of video and not at the beginning of video, because I do not want to waste your time at the beginning of video and focus on the matter. So thanks again for watching the video. Happy programming. I'll see you in the next video.